going to see class 9 maths, the chapter 6 lines and angles part 3. The topic, today's topic is angles of property of a triangle and exterior angle property of a triangle. And you know, the angle sum property means sum of the angles of a polygon. Here the polygon is a triangle. So in a triangle, if you take a triangle, for example PQR, okay, how many angles are there? 3. So only we are calling it as triangle. So if you sum up all the 3 angles, you get 180 degree. Okay, so the sum of the angles of a triangle is 180 degree. PQR, in this triangle, angle 1, angle 2, angle 3, I marked it. So if you add all the 3, angle 1 plus angle 2 plus angle 3, which gives 180 degree. So this is the angle sum property of the triangle. And coming to the next topic, exterior angle property of a triangle. You see here a triangle PQR where one side QR is produced or extended to up to the point S. Okay, this is the extension of one side. Okay, now here we can see the angle PRS. Okay, that angle I marked here as angle 4. Okay, that angle 4 is called exterior angle. What? Exterior angle. So here, if a side of a triangle is produced, the exterior angle so formed is equal to the sum of the two interior opposite angles. Sum of the two interior opposite angles. I told you what is the exterior angle. Okay, but the two interior opposite angles, that means here I mark the angles of the triangle as 1, 2, 3, 1, 2, 3, and this 4 is called exterior angle. Okay. Now, angle 1 and angle 2 are opposite angles of this angle 4. Clear? What about 3? Angle 3 is adjacent to angle 4. So, angle 3 is inside the triangle and angle 4 is outside the triangle. Okay, so they are adjacent angles. So now for angle 4, angle 3 is the adjacent and angle 1 and angle 2 are the opposite angles. So here two interior opposite angles is used. Okay, so now this angle 4, that is the exterior angle, is equal to angle 1 plus angle 2, sum of the two interior opposite angles. So 1 and 2 are the interior and opposite to angle 4. So the statement is, if a side of a triangle is produced, the exterior angle so formed is equal to the sum of the two interior opposite angles. So you can write here by observing this triangle, angle 4, which is the exterior or external angle, that is equal to angle 1 plus angle 2, sum of the two interior opposite angles. Clear? So using these two properties, we are going to do the exercise 6.3. Now coming to the exercise 6.3, first sum. So this is the figure given there, and the question is, in this triangle PQR, the sides QP and RQ are produced to point S and T respectively. You see, this RQ is produced up to T and this QP is produced up to S. So this is what given in the question. And angle SPR is 135 degree and angle PQT or SQT, anyway, because along this line only P and S are there. So in this question, it is given PQT is 110 degree. So this is what given that, and the question is to find PRQ. They are asking to find PRQ. So just for our convenience and for better understanding, I am taking this angle as small a, this angle as small b, and this angle PRQ, which is to be found, that I taken as angle C, small c. Okay. And now, by observing this diagram, first of all, 135 and angle A are what kind of angle? What pair? Linear pair. Am I right? Because this is a straight line and these two are adjacent angles, and these adjacent angles are in a straight line. Therefore, if you add, you get 180 degree. So they are linear pair of angles. So using that concept here, we can find angle A and also angle B. Angle A means nothing but QPR. With direction, if you say, that is QPR, and angle B, that is PQR, and angle C, PRQ, which is to be found here. To find angle PRQ. So first of all, we find, let us find angle A from the figure. Angle A plus 135 degree is equal to 180 degree because of linear pair. Linear pair of angles. And now A equal to 180 minus 135 degree, and A becomes what? 45. Okay. And taking this line, B and 110 are linear pair. They are adjacent and also linear pair. Okay, because these two adjacent angles are on a straight line. So these two angles are straight line angles, which is to be 180 degree. Therefore, also we can say angle B plus 110 degree is equal to 180 degree. So angle B equal to 180 minus 110. You get 70. Am I right? So now we have found A 45 degree, B 70 degree, and now easily you can find angle C by applying the angle sum property. Am I right? So in triangle PQR, by angle sum property, we can take angle A, angle B, and angle C, that is equal to 180 degree. So what is A? We already found it, that is 45 degree. So you can write 45 degree plus what is angle B? 70 degree. So you write 70. And then C equal to 180 degree. So if you add these two, what you get? 70 plus 45, 115. So 115 plus C equal to 180 degree. So C equal to 180 minus 115. So what the answer? Therefore, angle C is nothing but PRQ. That is what we have to find. So PRQ is equal to 180 minus 115, 65. So that is the answer. Clear? So now we got angle PRQ is equal to 65 degree, and we move to the next sum. Now coming to question number 2. So this is what the figure given, a triangle XYZ. An angle X is 62 degree, and angle, this is Y, is XYZ, because here the angle X is not disturbed. Okay, it is not divided, but here angle Y is bisected and angle Z also bisected. So we have to take as XYZ. that is 54 degree, and then we have to find these two angles. So how it is formed? It is given the question. Okay, because this is the bisector of this angle. XYZ is bisector, this angle bisector is OY, and this OZ is the bisector of angle XZY. So these two bisectors meet. These two bisectors. So this bisector is the angle bisector of XYZ, and OZ is the angle bisector of XZY. They two meet at the point O. And now the question is to find this angle YOZ and OZY. So just I named here for our understanding. This is small a and this is small b. So we have to find these two angles using the given data. Is it clear? So now, first of all, we have to be very clear about the given figure. What is given part and what is the question part. So we have to observe very carefully. And now, just angle x and this angle XYZ is given. We try to find the full angle XZY. Clear? So from the figure, angle x plus angle XYZ plus angle XZY is equal to 180 degree because of angle sum of triangle XYZ. Clear? Angle sum of triangle XYZ. You see the property. We can write the sum of the angles is 180 degree. And now angle x is given that is 62 degree. So this implies 62 degree plus, and XYZ is given that is 54 degree. So 54, and then XZY we can easily find. So this is 180. And now, if you add these two, 62 plus 54, we get 6 and then 7. So 116 degree plus x is y. That is 180. And now keeping here x is y, you can write 180 minus 116. So therefore, x is y. Is equal to 180 minus 160, then it is 64 degree. Right? So this is the measure of angle XZY. XZY of this triangle XYZ. Clear? Now, after knowing this angle, already we know this full angle XYZ and this angle XZY. Now we have found. Using this, we can find the answer. So XZY is bisected by this OZ. So we can take, since OZ is the bisector of XZY. Angle XZY, comma, we can take this angle B alone. So that is what we have to find. So we can take this angle B. So that is easy to understand. So angle B is equal to half of angle XZY. So clear? And that is equal to, what is the measure of XZY? 64. And we get that is 32 degree. So what is B? OZY. Therefore, OZY angle is 32 degree. So that is what we have to find. In the question part is given, find OZY, angle OZY. So we just found it. And using the same, here this OY is given, YO or OY. Both are same. So YO is the bisector. Since YO is the bisector of what angle? XYZ. of XYZ. Then we can take this OYZ, that is nothing but half of what? XYZ. So it is nothing but half into what is XYZ? It is given 54 degree. Look, XYZ is 54 degree, it is given in the question itself. So we can apply here. And what is half of the 54? 27 degree. So therefore OYZ, the angle measure of OYZ is 27 degree. Now in this triangle OYZ, we focus here. In this triangle OYZ, okay, we know OYZ, that is 27 degree, and OZY, that is here I named as B. Okay, so OZY, that is 32 degree, and now we have to find this YOZ. So this was the question. Find YOZ. Okay. In triangle OYZ, by angle sum property, we can say this is angle A, angle B, and this angle OYZ, like that we can take angle A plus angle B plus OYZ equal to 180 degree. What is A? We know this A is, we have to find, that is nothing but YOZ. Okay, plus what is B? So B is here 32 degree, and OYZ, so just now we found that is 27 degree. So we can put it, that is equal to 180 degree. And if you add these two, what do you get? YOZ plus 30 will be 50. So 59 degree equal to 180 degree. Clear? And then you see, I am writing here. So YOZ equal to 180 minus 59 degrees. You see, 180 minus 59 degree. So now therefore angle YOZ measure is equal to, what is 180 minus 59? 121 degree. So now we have found YOZ also. So first of all, they are asking OZY and then YOZ. You see here we found it, and here also we found it. So these are the two answers, OZY and YOZ. Clear? And now let us move to the next question. So now coming to question number 3. So this is the figure given there. So they are telling that AB is parallel to BE. So given AB parallel to BE, and you know, if the parallel line exists, then we can consider a transversal. Definitely will be there. So the transversal AE is there. So by using this transversal, we can say this 35 degree and this angle A. So these two are A and B. Just for our convenience, I given the name this angle DCE. You see, this is what to find. Okay, DCE I named as angle A, and this angle DCE is I named as B, and this angle DEC I just taken as angle A. Okay, sorry, you just take the angle A and angle B. Okay, DCE means angle B and DEC is angle A. So now this 35 degree and this angle A, can you say what pair of angles? Alternate interior pair of angles, because if these two lines are parallel, AB and DE, and AE is the transversal, then we can say this 35 degree and this angle A are alternate interior pair of angles, and they are equal also because the lines are parallel. So using that concept here, we are going to find the angle DCE. So DCE I named as angle B. Okay. See here, AB parallel to DE and AE is a transversal. AB parallel to DE and AE is a transversal. That means we can say this angle 35 degree and angle A. Angle A is equal to 35 degree. In bracket we can write alternate interior angles. Alternate interior angles. So they are equal. And now in this triangle CBE, now only we found A and already 53 is there and B only we have to find. So that is what DCE. To find DCE, very simple. Now in triangle DCE, using addition property, you know what is that? So you can easily tell angle A plus angle B plus 53 degree is equal to 180 degree. So what is A? 35 plus B plus 53 is equal to 180 degree. And now we can have 35 plus 53 means 88. Right? 88. So 88 degree plus B is equal to 180 and B is equal to 180 minus 88. So B equal to 180 minus 88. So if you subtract 80, it becomes 100 and further 8 means then you get 92. So therefore what is B? DCE. And DCE is equal to 92 degree. Clear? So this is the way to find the measure of the angle DCE in this sum. Clear? And now go to the next sum. And now the next question. This is fourth question. So it is given this diagram and PQ and RS, these two lines meet at T. The point T, that is the point of intersection of the two lines PQ and RS. Okay, and now you see we have here one triangle and here another triangle. These two angles are given and this one angle also given. You see here PRP, PRP, that is 40 degree. RPT 95 degree, RPT, that is this angle 95 degree, and PSQ, that is 75 degree. This is what given there, and the question is to find SQT, this angle. Clear? SQT, the center level only the angle, but the direction we have to say SQT. Okay. And now what you do? You see, in this triangle. Okay, this angle, third angle, two angles we know already given. Third angle we can find by using angle sum property. Am I right? And if we know this angle, we can easily find this angle. Am I right? Can we say what pair of angles are there or what the concept we can use there? So these two are vertically opposite angles because PQ a line, RS another line, they intersect at a point P, therefore vertically opposite angles equal. So these two are vertically opposite angles. So another pair these two. So this angle and this angle. But we now here we don't need that now. So these two only we need here. So if you find this angle, we can take SPQ angle equal to this one, and after that from here this angle, this triangle, two angles we come to know, and then the third angle we can find by using angle sum property. So first angle sum property, and again vertically opposite angle concept, and again angle sum property. Then we can find the answer. Clear? So the solution part, the first one, in triangle PRT using angle sum property, we can write 95 plus 40 plus PTR equal to what? 180. Clear? And now these two if you add, what do you get? 135 plus PRT by PTR, that is equal to 180 degree, and angle PTR is equal to 180 degree minus 135 degree. So this is, we can easily find 180 minus 135, which is 45 degree. Am I right? So now we found PTR angle. So therefore, if this is 45, then this also 45, vertically opposite angle. So now SPQ angle is equal to PTR. We can write like this because VOA. I already told you VOA means vertically opposite angle. I told when I got this vertically opposite angle. Am I right? And now, therefore, SPQ is equal to what? What is PTR? 45. So we can put 45 degree. And now this becomes 45 degree. Now out of three angles in this triangle, we have two, and the third one we can easily find by applying the same angle sum property. Can you do this as homework? Can you fill it? Okay. Thank you. And next sum, we will see the two more sums are there. And now coming to question number 5. This is the diagram given there, and the given part PQ parallel to SR. So you see the diagram carefully. PQ, SR, both are parallel. Another one, PQ perpendicular. The symbol refers to perpendicular. PQ perpendicular to PS. So this is PQ. And perpendicular to PS means then we can have this angle as 90 degree. Am I right? So they mark like this they mark. So it represents 90 degree. So these two are parallel. We can mark like this. And this side, that means this line SR is produced up to T. So ST. Okay. So PQ parallel to SR, and then the same way it is produced. Now SQR 28 degree is given and QRT 65 degree is given, and they are asked to find X and Y. So you see how to find it. So now look at the figure. PQ is parallel to SR, and we can take QR as a transversal. So wherever you come across the parallel line, you can observe a transversal there. From that we can take any alternating angles equal or co-interior angles. So like that it will come. Okay. So now here we can apply, that is this full angle. So QR, if we take transversal, QR is here transversal. So we can have this full angle, that is PQR. You see, what I'm writing, PQR angle is equal to QRP. You see the diagram carefully. PQR and QRP, they both are alternate interior angles. Since the lines are parallel, they are equal. So the reason is alternate interior angles. Okay. So now PQR is what? X plus 28. X plus 28 degree. That is equal to QRP is what? 65 degree. So we can equate like this. And now X equal to 65 degree minus 28 degree. So therefore X is equal to how much? Okay, 37 degree. So now we found the angle measure of X. And now moving to the Y. To find Y, you see, you take this triangle PQS. In that triangle, this angle you know that is 90 degree because they gave PQ perpendicular to PS, so we have 90 degree, and X that is 37 degree. Then the third angle Y you can easily find by applying the angle sum formula. So in triangle PQS, by angle sum property, you can write first of all this angle QPS, you take QPS, and then angle X, and then angle Y, all together 180 degree. And what is QPS? 90 degree. Am I right? This is right. QPS is 90 degree plus X, that is 37 degree, and then plus Y equal to 180 degree. If we add these two, we get 127 degree plus Y equal to 180 degree. So Y equal to 180 minus 127. So now therefore Y is equal to 53 degree. Am I right? So this is the way to find the answers for the given question. X and Y they are asking, and we found the value, the angle measure of both X and Y. And the next question 6. And now coming to question number 6. So this is what the figure given there. And here, so far we used angle sum property, but here we are going to use exterior angle property of a triangle. So in this figure, triangle PQR, you see PQR is a triangle. So the side QR is produced up to S, and then PQR is the angle and QT is the bisector of this angle. QT is the bisector of angle PQR. That means what? This angle and this angle, these two are equal because QT is the angle bisector. And PRS is this angle. See, PRS. In this angle, RT bisected. Therefore, you see double mark I given here and mark there. So these two angles are equal. Clear? These two angles. For example, if we want, we can take as number 1. This is 2. 1 and 2 equal. Here 3 and 4 equal. Because RT bisect PRS. Clear? And QT bisect PQR. Therefore, 1 and 2 equal. Clear? So this is what given there. These two bisectors meet at T. This is given in the question. Bisectors QT and RT of these two angles meet at the point T. So you have to understand the question first of all clearly, and you have to prove QTR. You see that QTR is here. Here QTR is equal to half of QPR. QPR is here. So QTR is equal to half of QPR. This is what we have to prove. So for that, how we are going to prove it? So first of all, in this triangle, we take QTR triangle. First of all, in triangle QTR, angle 4 is the exterior angle, right? Angle 4 is the exterior angle. So exterior angle of a triangle is equal to sum of the two interior opposite angles. Can you say what are they? You can name it. This is 5 and this is 6. For our better understanding, just we are writing the numbers. Okay. You see, angle 4 is equal to angle 5 and then angle 2. Clear? In this triangle QPR, angle 4 is the exterior angle because this is extended. So this is exterior angle, and 2 and 5 are the two opposite interior angles. Clear? 2 and 5. So you can write like this: in triangle QPR, which is the external angle, angle 4. Angle 4 is the external angle. So therefore we can say angle 4 is equal to angle 2 plus 5. So why I am writing the number means you have to understand clearly. But here we have to prove like this. We have to prove QTR is half of QPR. So now we can write what is angle 4? TRS is equal to what is angle 2? That is TQR. Then what is angle 5? QTR. Here also you see we can write QTR as RTQ also, but when answering and in the particularly proof sum, we have to see what we have to prove. So accordingly we have to write the names. Okay, QTR, QPR, right? So another QPR. So wherever you face this QPR, we should not write RPQ. That also correct, but we have to follow the same pattern QPR. So then only it will be convenient to observe where the angle is. Clear? So these are some tips. So TRS is equal to TQR plus QTR. So here QTR in the right side. So but in the proof QTR is there. So we keep QTR at one side and transpose other things to right side. Clear? So this implies we can write this as QTR. You see, QTR is equal to, you see, QTR is equal to TRS minus TQR. TRS minus TQR. Clear? QTR I'm keeping at one side. If you transpose TQR to that side, what happens? TRS minus TQR will come. So at one side I have written TRS minus TQR. Is it clear? So you keep this as equation 1. And you will see how we are going to apply this equation. So now you consider triangle PQR. Okay. First of all, we take QPR and angle 4 is the external angle. And if you take PQR triangle, then PRS is the exterior angle. Okay. In triangle PQR, what is the external angle? PRS angle is the external angle. Clear? Clear or not? TRS is the external angle. You see, PQR in this triangle, QR is used, therefore PRS is full angle. Clear? This full angle. Now becomes external angle of triangle PQR. Clear? And which is equal to sum of the two opposite interior angles. Can you say what are they? 6 one angle, another one is both 1 plus 2 we have to say. So for that PQR is better, right? Clear? So we can write PRS exterior angle, that is equal to angle 6. What is that? QPR plus, and then 1 plus 2, that is both we have to add and take. So angle 1 and angle 2 together we can say angle PQR. Clear? And now just we can write from here PRS, in this PRS angle, you see we can write TRS as 2 into PRS. PRS is 2 into PRS, right? Because you see how I am writing. PRS has substituted as 2 into angle TRS. You know what? Because TRS is also here in this equation. So we have to try in the same pattern. So TRS, that means this is half of the PRS. Or you can say 2 into angle TRS is equal to angle PRS. Am I right? Because RT is the bisector of angle PRS. Clear? So this angle TRS, that is angle 4. Clear? This angle is, we can say half of PRS. In other words, PRS is equal to 2 into angle TRS. Clear? So I am writing here 2 into angle TRS. And now QPR. So QPR is not a problem, because we see the next one PQR. PQR, you see the bisector is there, QP. So PQR. So angle 2 and angle 1 are equal. Am I right? Because QT is the bisector. So you write this as QPR. QPR is, here we have QPR in the proof. So don't disturb that. Let it be QPR. Clear? And now PQR angle I am going to write as, you see clearly, carefully, PQR, that angle. In this angle, here I am going to write 2 into PQR. 2 into angle PQR. You see, this angle 2 is half of PQR. Am I right? Look carefully the diagram. Angle 2 is the half of PQR. Is it clear to you? Because QT is the bisector of PQR. So angle 2 is half of PQR. If you want, you can write for our understanding. So angle 2 is nothing but half of PQR. Okay. Suppose if you take this here, what is angle 2? That is TQR. Angle 2 is nothing but TQR. So this implies 2 into PQR is equal to, if you bring this 2 to right the left side, 2 into PQR is nothing but angle PQR. Clear? Now you see 2 into angle PQR is equal to PQR. So instead of PQR, I wrote 2 into angle PQR. PQR is equal to 2 into angle PQR. Now is it clear? So why I am trying to write PQR means, because here in the equation 1 we have PQR. So we are trying to write that. So here also like that. Here PRS is there. So for PRS, I am writing 2 into angle PRS. So this is the way of proving. Clear? So this is a simple one compared to the other problems. And not in this chapter, in other chapters. So we have to be very care in the diagram, and we have to watch it, and then we have to compare and write this. So I think you understand well how I wrote PRS as 2 into PRS and PQR 2 into TQR. Clear? And now we are in the final position, and now you see QPR and keeping at one side 2 TRS 2 into TRS minus 2 into TQR. I am writing like this, just transposing the side, keeping QPR at one side. If you take 2 into TQR to this side, what happens? 2 TRS minus 2 TQR will come. Is it clear? Just transposing and keeping QPR angle at one side. That's it. So you see, this is nothing but 2 into TRS minus TQR. And now 2 into, what is TRS minus TQR? QTR from equation 1. Easily we can substitute that. QPR from equation 1. Since from equation 1 we can substitute QTR angle instead of this bracket. So this bracket is there, TRS angle minus TQR angle. And now you see QPR. So to keep on writing this to the left side, we have to do the equation. To prove it, we have to write. And now you see the proof part. So by seeing the proof part, you have to proceed. So QTR, that is equal to 1 by 2 into QPR. So if you bring 2 to the left side, it becomes 1 by 2. So everything okay. So this implies QTR is equal to 1 by 2 QPR. Right? So just you bring 2 to the left side, it becomes 1 by 2. So 1 by 2 into angle QPR. And I am writing this QTR here and then to the right side. So as the proof, that's all. So this is what we have to do. So we finished exercise 6.3 and also the chapter lines and angles. So worksheet will be sent to you. You finish it and make it everything clear. Thank you.